Now I will explain how this system, SMS home routing, could be bypassed by a hacker. SMS home routing introduces one more node into the mobile networks. This is the SMS router. And now, when some SMS center sends send routing info for SM request to the mobile network, STP, border STP, should send this message not to the HLR but to the SMS router. SMS router generates a fake IMSI address and send it and its own address instead of MSC's one in the response. SMS center delivers the SMS to the SMS router. After that, SMS router correlates incoming fake IMSI with initial MSSDN and performs the second HLR interrogation process. It sends send routing info for SM again inside the home network to the own HLR. HLR responds with real data, and SMS center delivers, not center, SMS router delivers the SMS to the correct MSC. We have two SMS delivery processes here. One of them is on the external side, another one is internal in the home network. And now, when the manufacturer appears in the SS7 and tries to receive IMSI, they send routing info for SM request and receive response with fake data. The network looks protected. And now to explain the bypass mechanism, I would like to explain in details numbering plans that are used in telephony or mobile telephony. The first couple of identifiers, MSSDN and global title. As I previously said, they have the same structure. They consist of three groups of digits. The first one defines the country. In this picture, it is Luxembourg. The second one defines the network in this country. And the third group of digits determines a subscriber. The second number plan defines IMSI. It also consists of three groups of digits. First one determines mobile country. This is Luxembourg again. The second group determines network within this country. And the third group is just subscriber-related digits. And the third numbering plan, this is a combination of the previous two. It is also consists of three groups of digits. First two groups come from the first type. The third group comes from the second type. And now, when some signaling message is addressed by this identity, it defines a destination operator by the first two groups of digits. It defines the rule of this address translation by the byte type itself, and defines destination node but by subscriber-related digits. Only HLRs can be addressed by this type of identity, by the third type. And now, let's look inside the STP and look how it works. When STP receives any signal message, this message goes to the routing table. If routing table defines the numbering plan of a destination node is E214 or the third identity type, it should involve one more translation table and define the destination HLR by subscriber-related digits. If the routing table faces that operation code is send routing for FRSM, it sends a signal message to the SMS router to involve SMS home routing procedure. And one more note: send routing for FRSM message is normally addressed by the first type of addresses, by MSSDN. And now, intruder appears in the SS7 network, and he knows all the information I have just given. He is able to compile send routing for FRSM message, addressing it by the third type of addresses, and address a subscriber by MSSDN. The routing table finds that the numbering plan is E214, or the third type of identities, involves appropriate translation table, and delivers this signal message to the HLR, not to the SMS router. HLR replies with the correct data. So the SMS home routing system is bypassed, and the intruder have all information he wants. One more technique to bypass SMS home routing. Again, when a subscriber appears in the SS7 network and trying to retrieve IMSI from some network, STP routes, for example, to the correct SMS, this message to the SMS router. SMS router replies with some data, but at the beginning, malefactor does not know if this data correct or not. He needs send the same message one more time, and if they see different IMSI identifiers in two responses, that means SMS home routing procedure works properly. Let's look at one of SS7 protocols, to TCAP protocol. This protocol consists of several blocks. First two blocks are mandatory. They are message type and transaction ID. Then dialog portion follows. This block contains application context name parameter. Application context name identifies the following operation. Operation itself is coded in the fourth block, component portion, and it has their own code. Application context name and the operation code should correspond each other one by one. But these are two different values. And now, application context consists of a group of some numbers. Each number has their own value, own meaning, and only two final numbers defines application context name and the version itself. All previous numbers are usually constant. But what happens if a malefactor changes one of these constant values to some unidentified or unknown value? Let's see. Let's again. A malefactor appears in the SS7 and send routing info for FRSM message with the corrupted application context. STP, this is fantastic, but one bit influence that STP routes this message not to the SMS router but to the HLR. HLR, of course, responds with correct data. And if this intruder wants to check if this request retrieves the correct data, they can send this message one more time, and IMSIs are equal. So SMS home routing procedure does not work. One more case with bypassing of the SS7 firewall system. But now, first, I would like to describe a typical deployment scheme of the SS7 firewall. When some signal message comes to the border of the operator, it comes to the STP node. STP routes this message to the SS7 firewall. SS7 firewall inspects all the message layer by layer, and if SS7 firewall defines the message is hostile, it just blocks it. Otherwise, SS7 firewall sends the message back to the STP, and the STP delivers it to the destination node. Now let's recall this slide from the very beginning, and I would like to focus your attention on send routing info message. This message is used in each voice call. That's why it should not be prohibited on the HLR. It should be blocked on the border, because this message is used internally in the operator, not between different operators. And now, our intruder send routing info message to the network. STP routes this message to the SS7 firewall. SS7 firewall detects that the message comes from somewhere abroad and just blocks it. That works good. And now, let me remind you this slide with application context, corruption. And our intruder is able to send routing info message with malformed application context. And STP, this is fantastic again. STP routes it not to the same firewall, but directly to the HLR. And HLR responds with correct data. SS7 firewall is bypassed by 1 bit